I'm going to perform for you the battery hydrometer test. What we're going to be doing is comparing the individual cells, there's 6 of them, of this cranking battery. And we're going to compare them to see if all of the cells have relatively the same amount of charge. I'm going to be using an old style or a generic hydrometer. It shows up best on the video. I prefer to use a temperature compensated or a refractometer. They're a little bit more accurate based on temperature. But I'll show you how that works, and you can apply those readings or corrections for temperature to the generic one as well. Other things I've got ready, an old screwdriver to pop the caps off, some baking soda, paper towels. You don't want any red shop rags around. If you get battery acid on a red shop rag, it's going to eat it up. Safety glasses are a must anytime you're working around a battery, especially if you're going to have the caps off and be working with battery acid. The concentration of the battery acid is no more than around 40% sulfuric acid diluted in water, but it will irritate your skin and it can do some serious unrepairable damage to your eyes, so make sure you have your eyes covered. Piece of paper to write my results down. I'll start by popping the caps off. I've got the negative post situated on my left. Positive post is situated on my right. Take a quick glance down inside the cells. Make sure that they all have sufficient electrolyte so that I can pull a full sample without drawing any air in. On this tool, I need to fill the entire hydrometer. There's a fill line, and then based on the specific gravity of the electrolyte, there's a needle that will float. So since the needle is moving, I have to have the hydrometer straight up and down, and there's a little crosshair here with a needle in that area as well. And draw in a full sample. This hose has got a couple kinks in it, so I'm going to make sure that I kind of hold the kinks. Here we are, full sample. My hydrometer reading is 1.210. So I look right in there, and then I'm going to write down 1.210. Return the electrolyte to its cell, and I move to the second cell. Good squeeze. Full reading. All right. This cell is 1.250. A little higher yet, between 1.250 and 1.275. So I'm going to call that 1.262. And a little closer to 1.250, again in between 1.250 and 1.275. So I'm going to call that 1.2 0.55. All right, moving on to the 6/5 cell. $1.275. And the last cell. I drew some air in that time, so I did not get a full sample. So I'll start over on that one. $1.250. All right, so we take a look at our readings. We're going to take the highest reading, the 1.275, and subtract from that the lowest reading, which is 1.210. So we subtract those two, we get 0.65. The largest variation that we allow between cells is 0.050, which we call 50 points. Since this battery exceeds that 0.50 margin, we are going to condemn this battery and say that it is indeed bad. As I mentioned earlier, I prefer to use a hydrometer that's temperature compensated. The advantage here is if I want to know if this battery has a sufficient charge in order to be tested, then I need to compensate for the temperature of the battery. And this hydrometer will allow me to do that. As I draw the electrolyte in, it passes across the bulb of a thermometer, and then you adjust your float readings based on the temperature. Another reason for doing a hydrometer test is just to measure the individual variations between the cells. So if I have a battery that fails a load test and I need to charge that battery, instead of spending time charging the battery, I can do a quick hydrometer reading and compare the variations between cells. If the variations exceed 50 thousandths, 0.050, then I know the battery isn't worth charging. It does indeed have a deficient cell, and no charging in the world is going to bring that variation back. It'll bring all the cells up, but it won't compensate for that one that's greater than 50 points off. So in looking over the results for this battery, our readings ranged from 1.210 to 1.275. We subtracted those two readings and got 0.065. All of the readings were a little low except for the 1.275. All of them were in the fair, and had this one been even 15 to 20 points higher, the battery would possibly need to be charged. A little backstory on this battery. This battery was left in a vehicle outside, and when we pulled the vehicle in, the battery voltage was around 5.5 volts. I am sure that this battery probably froze. I don't know whether that led to the variations between cells. But I put the battery on a charger after I know it was thawed, put it on a charger for 2 days. It's been on a maintenance charge. It tested marginal to good on a load test, but I wanted to see the general health of the cells anyway. And after testing the cells, we note that one of the cells is in fact deficient.